This is the second part of section 9. JSteele's Precalculus section 9.3. We're dealing with solving systems of linear equations with several variables. So we're on our final example number 3. And our goal is to eliminate 2 variables so we can just solve for one single variable. Looking at equations 1 and 3, we have a single x term and a single z term and a single x term and a single z term. Notice all 4 of those x's and z's are positive. So if we take the top equation and multiply it by -1, then we have a negative x minus y minus z equals -2. So now we have a negative x and a negative z. The third equation, we still have a positive x and a positive z. So if we were to add these 2 equations, so positive x minus 2y plus z equals 4. If we were to add these 2 equations, our x terms and our z terms will cancel. They will reduce. And we're left with -3y equals 2. So I'm just solving for y, so divide that by -3. So we have y equals -2/3. So now, if we were to plug this into the top original equation, then we have x plus -2/3 plus z equals 2. And then plugging it into the second equation, we'll have 3x plus 3 times -2/3 plus 3z equals 14. So then, for the first part, if we have x plus -2/3 plus z equals 2, let's add the 2/3 over, and then we have x plus z equals 8/3. Let's just find a common denominator. And then for the other equation, if we just simplify, we will have 3x minus 2 plus 3z equals 14. Adding the 2, we have 3x plus 3z equals 16. So now we have 2 equations with x and z. Since we have 2 equations with x and z, we can now either use substitution or elimination to solve for another variable. If we multiply this first equation by a -3, then we will end up with -3x minus 3z equals -8. So that's one equation. And then we also have a 3x plus 3z equals 16. That's just rewriting the same exact equation. And now adding these two equations, the -3x plus 3x, that reduces. The -3z plus 3z reduces, and we're on the left-hand side, we're left with 0. -8 plus 16 equals +8. Now we ask ourselves, is this a true statement? Certainly, 0 does not equal 8, so we can write no. Anytime we have a statement where we say no to, that answer is no solution. The bookwork that will be worked on during class will be on page 657. It's numbers 1 through 9 odd and 15 through 19 odd.